Very good afternoon, all. I am Dr. Amit Biswas from Agriculture Engineering Department of Health Institute of Technology. Today, I am going to deliver one lecture on the topic of importance of water quality in agriculture. So now, at first, we have to know what is agriculture. So its origin basically agar or agri, that means soil, cultura, that means cultivation. So in combination, it is agriculture. So it is basically one kind of applied science which covers crop production, fisheries, livestock management, etc. So now for agriculture, irrigation is utmost important. So for that purpose, for irrigation purpose, water quality is prime important. So important water quality parameters for agriculture are mentioned in this table. So what are the parameters? First one, physical parameters. Second, chemical parameters. Third one, microbial parameters. So one, physical parameters. So what are the major physical parameters in compounds? It is temperature, color, odor, turbidity, total suspended solids, taste, and electrical conductivity. So its concerned risks are clogging of agricultural irrigation system. Now the chemical parameters. What are the major parameters? It is acidity, pH, total dissolved oxygen, biological oxygen demand, alkalinity, chlorine, hardness, chemical oxygen demand, COD, and so many heavy metals. So its concerned risks are soil and groundwater pollution, crop growth and quality are affected due to chemical contaminants. Now the microbial parameters. It is bacteria, algae, and viruses. So its concerned risks are soil and groundwater pollution, crop growth, and its quality. Now, for water quality, water limit, the standard limit for irrigation are mentioned from so many international organizations. So here, some water quality standard for agricultural irrigation. So first one is pH. It should be between 6.5 to 8.5. Electrical conductivity in decimen per meter, it will be up to 3. Total dissolved solids, and all other parameters are in the unit of mg per liter. Total dissolved solids, its limit 700 mg per liter. Its BOD, it is 30. COD 90. Ammonium 5. Nitrate, it is 10. Total nitrogen, it is 30. Phosphate, it is 2. Potassium, it is 2. Lithium, 2.5. Sodium, 100. Manganese, 0.2. Iron, 5. Cadmium, 0.01. Chromium, 0.10. Lead, it is 2. Nickel, 5. Boron, 2. Arsenic, 0.10. Fluoride, it is 1. Carbonate, 100. Copper, it is 0.10. Mercury, it is 0.02. Molybdenum, it is 0.01. Selenium, 0.02. Vanadium, 0.10. Zinc, it is 2. Detergent, 5. Sulfate, 500. Chloride, 250. Beryllium, 0.10. So all the data are collected from Biswas et al. 2021. Now sodium absorption ratio. So as it is a ratio, it has no unit. So its limit is 3. And fecal coliforms per 100 ml, it should be number of counts. It is only 200. So all these limits are standard for agricultural irrigation purpose. So when agricultural irrigation will be provided to the crops, so all these standards have to be checked first. So now the worldwide scenario of wastewater in agriculture. China, India, Pakistan, Colombia, Ghana. So many countries are using wastewater in agriculture. So it is the data for raw wastewater application in agriculture. So here, why wastewater is required in agriculture irrigation purpose? Because it is rapid urbanization, freshwater scarcity, improve, and it will help to improve crop productivity and less freshwater footprint, increase NPK, nitrogen, phosphorus, potassium to soil and crop, increase micronutrients to soil and crop, and it is cost effective. But when we are using raw wastewater in agriculture irrigation purpose, so it involves some serious threats to human health as well as the crop health as well as the soil health. So some of the effects are tabulated here. One is toxic heavy metal contamination. Second is bacterial contamination, polluted soil, contaminated crop, health risk of human being. Now we have to know the facts about groundwater. Of all water on the earth, only 1% is available for our use. So Earth's surface is covered with 29% of land and 71% of water. Out of 71% of water, 97% of water is salt water, which is present in oceans, seas, and saltwater lakes. Remaining 3% of water present on the land is fresh water, which is present in the form of glaciers, ice caps, groundwater, lakes, rivers, and in the atmosphere as water vapor. Out of 3% of fresh water, 2.5% of the Earth's fresh water cannot be used because it is locked up in glacier, polar ice caps, atmosphere, and soil, are highly polluted or lies too far under the Earth's surface to be extracted at an affordable cost. 2% of fresh water is found in ice caps and glaciers. 0.75% of fresh water is in the ground as groundwater. 0.009% in freshwater lakes. 0.001% in the atmosphere, and rest of the amount in the rivers. So it is the data related to groundwater. So here, as we all know that more than 70% water in the form of the groundwater is used for the irrigation purpose, and almost 9%, it is 8.75%, 8.7% is used for industrial purpose, and 1.2% is used for domestic purposes. So it is the statistics of groundwater uses. So now the wastewater irrigation on groundwater quality, how it affects. So it is uh, clearly shown when wastewater irrigation is practiced. So many heavy metals and other pollutants pollute the groundwater, soil, and crop. From this picture, it is clearly understood. Now, the wastewater irrigation on groundwater quality. What are the benefits? Wastewater generation and reuse benefits. At first, it will give the nutrient, it will reduce the freshwater load, and impact on soil, plant nutrients, plant nutrients will be increased, toxic metal ions will be increased if we use the raw wastewater. Crop productivity will be improved as compared to the freshwater irrigation application, public health will be damaged because of bacterial infection, protozoa, viruses, helminthes, etc. Regular wastewater irrigation, it is involved pathogenic contaminations, fertilizer use, salinity problems, toxic constituents. So now for this, wastewater treatment is utmost important. So that's why wastewater irrigation should be practiced after treatment of wastewater. Now some case studies of impact of untreated wastewater irrigation. So here from this study, it is Devnath et al. 2014. The wastewater application, the impact of uh, untreated wastewater irrigation is the microbial load, physico-chemical characteristic, and the heavy metals in wastewater was found to be higher side, and predominant presence of iron, copper, and chromium posed a major concern. So it is basically the iron, copper, and chromium contaminations were there due to application of untreated wastewater irrigation in this study. Another study, it is Idin et al. 2015. The same thing, the highest concentration of lead, copper, chromium, cadmium, zinc, nickel, and mercury in wastewater irrigated soils were 5.32, 37.1, 31.5, 11.4, 91.5, 134, and 0.34 milligram per kg respectively. Wastewater irrigated soils were strongly polluted by cadmium and moderately or strongly polluted by nickel and others and by other heavy metals. Same scenario was also observed in the Al-Naimi et al. 2021, and it is the long-term impact when you are using the wastewater for agriculture irrigation purpose in long term, so it will affect the soil very dangerously. So many heavy metals, microbial contaminations will be there in the soil, and this study uh, proves that. Now another study is 8 Mohab et al. 2022. It is also same. The chlorine, electrical conductivity, sodium, so all are increased due to raw wastewater application in the drip irrigation for lettuce. Another study is assessment of environmental impacts in the untreated urban wastewater irrigated sites. So here also same scenario were followed. So it is in the case of Adurai, India. So lead copper contaminations were there in the raw wastewater application in irrigation purpose. So from this study, we can conclude that raw wastewater irrigation is harmful for soil, crop, as well as the human being. So for that purpose, we have to reclaim wastewater at first, and after that, we can apply it for our agricultural crop production. Otherwise, it will affect overall environment. So in the next video lecture, we will discuss wastewater treatment and its application in agriculture. Thank you.